I will give a presentation then from Kongsberg regarding the safety work that we have been doing on the string test. First of all, my name is Hans Westad. I've been the project manager for the whole project from start to very soon finish. And together with me today, I have Lars-Petter Nygaard, who has been the site lead or manager when they're starting the testing and completing the commissioning of the string test. First of all, I just want to give regards to EU for funding the project. It has been a very interesting project with a lot of learning, and so it's been a nice project for us. When we started on the safety system and how we wanted the string test to be designed, we started actually on looking on the design for the vessel. This was not the vessel that we ended up with, or at least the design, but it was the initial design, and we used that design to map this into the string test to be as equal as possible then for the safety view of it, and made us able to reuse a lot of the safety philosophy and design over towards the vessel on the later stage. When we look at the full string test and the site, then I think I will just go through. Outside at the site, we have a hydrogen storage container delivered from Linde, and then we had 2 fuel cell containers containing 3 fuel cells each. Those was delivered from Ballard. Then we had a battery container containing 4 battery strings, 2 to each side of the switchboard, and a firefighting system for the battery as well. And we have also had 2 load banks. One is replicating or simulating the load from the azimuth thruster, and one for the tunnel thruster. That enables us to complete the testing then of the rest of the system without actually having the thrusters. Inside we had grid transformers and multidrives then, or the switchboards. The string test itself has enabled us to learn a lot about the system safety related to hydrogen and the commissioning, both related to hydrogen and integration of the hydrogen between the storage and the fuel cells, but also new functionality related to DC switchboards and functionality that we have developed during this project. And we had a lot of system testing together with FMEA testing them to be sure that we have a safe system. The energy management optimization, we have done a lot of testing with the same load profiles over and over again, and just adjusting the energy management, how we utilize the fuel cells together with the batteries, and see how we can optimize the energy management for this kind of system. Also some certification testing together with Lloyds and acceptance test at the end to show that we actually have accomplished and complete all the obligations related to the contract with EU. So that is kind of the whole setup for the test. And when we look a little bit into the hydrogen system itself, this is a clean ID. And this is the hydrogen storage, where we have 12 hydrogen packages containing 100 kilos in total. And they are linked together in this central on, I think it's 200 bar, the pressure on the high pressure side. And then we have some reduction valves down to 15 bar, which is the main flow out of the hydrogen storage and into two different cabinets for distribution towards the fuel cells. Inside this hydrogen storage, we also have included some one-directional valves to make sure that in case of a leakage, we only have one of these packages that are actually leaking and not all of them. We also have some valves to shut down through the emergency system, and also some manual valves to shut down and also to bleed out if we need to do some kind of maintenance on the system. Yeah, inside this distribution cabinets, we have split into, so we have one pipe into each of the different fuel cells. We started early with the hazard zone plan together with the land requirements for hydrogen storage, distance towards buildings and so on. But this is showing then the hazard zones with the zone 1 and 2, which is of course around the hydrogen storage. This is the ventilation from the container. This is the fuel cells, and it's only a hazard zone inside the fuel cells. It's not supposed to be able to leak, but I guess Ballard will say more about that. And this is the safety zones around the distribution cabinets. And also the battery container has a hazard zone, and of course that can also generate hydrogen if we have a lot of heat inside the battery container. The next step was to look at a hierarchy for the fire and gas, where we can have different kind of events and then put them together to see what kind of actions that actually need to be done. And this is one kind of technique then to design the fire and gas system. So this is a space called the fuel cell space in the container, and this is kind of what the sensors and events that we can detect them and the actions that go in downwards. It's not easy to see, but it's just a kind of showing what about the work that has been done. Then we have the sensor layout, and again for the hydrogen storage we have two gas sensors and one flame detector for the fire. And outside the container we have an emergency shutdown button that you can push them to just shut down the hydrogen storage. Then we have this fuel cells containers with gas sensors inside each of the fuel cells, but also one kind of taking the whole container as well. And this outside the door of this, we also have emergency shutdown button, so you can shut down either the one of the containers and the both containers together. And the same is then for the battery tank or the battery container. Outside the door for when you can go inside, you have a emergency shutdown that is for the complete system, and so then pushing that button will shut down the complete system. Yeah, I think that's okay. A lot of the information then from the hydrogen for the hierarchy and the safety layout, it's the cause and effect, and of course this is not readable through this presentation. But here we have identified a lot of causes. This is in IO input into the safety system, where we can say that if this one occurs, you can see what is actually the effect that will have to the system. And you can see that some of these events or causes then generates a lot of actions then from the safety system, while other kind of minor events then generates just small actions then from the system and only goes to parts of the system. And finally, we have a critical alarm and action panel, which is located inside the control room, where we also have the energy management system. In this panel, we get the overall alarms from the system and also have emergency shutdown buttons that we can use to shut down the complete system or all the parts. Like for this, for example, we have a fuel cell container 1, and then we can shut down the complete container or each of the fuel cells, or already shut down the valve for the supplying the different fuel cells. So it's a panel that enables us to do segregation of the system and also shut down all the parts where you have can have issues with the system, and the rest of it is operating. And I think that will be important when we get this out on a vessel. Also to see to have an evaluation of the safety system that we have been doing, we hired in a third party to HySeas Safety, and they did a simplified HySeas and a design screening of the system that we had presented them for them. And the evaluation was in general based on the system at site to secure the working environment for the people at site, but we also had kind of a glance into how this safety design would transfer onto the vessel and see if that was suitable for the vessel as well. And we evaluated 4 different parts of the system. So it was the hydrogen storage, fuel cells, the electrical and batteries together, and also the ventilation and the hazard zones. And we identified some risks. It was tolerable risks, but some of them was mitigated after this design screening to secure the system. But we see that some of parts of the system was also kind of higher risk when we transferred it onto the vessel. So this was a good exercise together with a third party. Then I think we have some lessons learned that I will leave to the site manager to tell you about his first-hand experience.
Yes. Hello, I was one of the engineers doing the commissioning testing on site, and I will, as Hans told you, I will go through some of the lessons learned we have related to safety. The first one that we are going to talk about is this hydrogen leakage that we had from one of the gaskets on site. You can see it's actually in my hand on the image here. On the right side, this was it didn't fail, but it wasn't tightened hard enough by the people who replaced the canisters. So it was important that this was tightened to around 50 newtons approximately. And the problem with this is that when we did replace those canisters, they initially did work, no leak, but over time it kind of, the hydrogen found a way and it created a really audible leakage. I don't think it was a lot of hydrogen that leaked out. We were talking about 1 to 1.5 kilograms. but that's a lot of. It was a lot of time. Caused this fire department to come, and we had a complete shutdown. The safety system reacted accordingly. The alarms went off. It shut down according to the hierarchy with a gas alarm in the gas container, so the complete facility was shut down. So we have 12 of these connection points with a flexible hose to the Linde gas container, and it's important that all of them are tightened, and it's a work from an engineer side of point of view. It's something you do many times. You do it 12 times each time you replace it. So we had some learned lessons after this with a course with Linde to try to get more experience on how the hydrogen itself would react and where it would leak and the ignition sources and so on. It caused some reports afterwards, but it was a good lesson. This one. Another one that we want to highlight is the leakage over time. What you can see here is actually a trend from over 10 days from site with a closed system. These are closed valves on both ends of the fuel line, and we can actually see approximate 2 bars of reduction. We initially thought this was due to temperature changes, but the temperature during this time was quite stable. So it kind of made us do a little bit more digging because some of the gas sensors have actually detected this, but it's below the alarm limit. It was detected around 200 ppm, which is in some cases have caused a pre-warning, but it's not so high that it will cause a shutdown. And it's also outside the ignition range of the hydrogen, but it's an observation done over time, and it's also a preferred way of showing leaks that you may have in your system, even if they are really small, is to do this over time and have proper trending and proper actions done to limit it. And as I said, this was over 10 days just before Christmas, so there was no one on time, no one on site. So this was an observation after. And for this system, we have 200 bars on the main canisters, and with pressure reduction, there will be leakage through the reduction valves. They all have specified leakage rates, so it's actually to be expected. And the chemistry of the hydrogen is quite small, so it kind of finds a way. We also installed after this incident of the big leakage. I will just go back towards the P&ID. On the middle here, it's not, of course, it's not visible, but this is actually a pressure release that we can do a manual release. So when we left the site, we closed, of course, all the valves, and we released the fuel pressure from around 15 bars to below fuel gas pressure, which was 8 bars, and we minimized the leakage over time in the fuel lines. That was when we left the site to avoid this. As Hans mentioned regarding the gas sensors, they are all located in gas tank containers and the fuel cell containers, but they are located in places where it's possible to have it accumulated. And the system is built for ventilation. The fuel cells, of course, but also the gas container, that the hydrogen is expected to leave the area. And it rises up quite fast, approximately 25 meters per second when it's released. So it's important to handle the leakages when they do occur. That's the 2 main points I wanted to highlight for the safety part. If there are any questions, please raise your hand and we will try to explain, or go back if that's needed. We're open for questions. Yes?
What is, can we talk about what went right with the safety alerts when the hydrogen was leaked?
Yeah. I don't have an image of the actual alarm, but it was the gas sensor in the container went off in the storage container, and that immediately shut down fuel valves. It shut down the ESD valve in the gas container. It closes off the load banks. It shuts down batteries. So it leaves the site stopped. So that went accordingly, according to the hierarchy and the cause and effect that we designed. So that was quite good to see. Of course, we did 100% safety test before we did any running of the plant in an operational state. We did commissioning and the conditioning of the fuel cells together with Ballard. But prior to doing tests or longer runs, we had a 100% test of everything, having everything run, and tested each sensor with hydrogen, flame detectors with a flame simulator. So we were quite confident that it would work, but immediately, a couple of months after, it actually did leak. So it was nice to see it going correct. Any more in-depth questions on what went right, Christina?
Yeah, no, I think it was just important to highlight that every safety thing that was in place really kicked off and worked like it was supposed to. And there was no damage, no injuries, no problems.
No, that's because that's the last thing we want, right, on a site like this, is to have injuries or big occurrences. But if it's one place we should experience this, it was on this test site. But it's a good experience to have seen this hydrogen in real life, and to see how it acts and how it kind of escapes, and what we need to do about the leakages when they occur. So, and the gas sensors are highly sensitive. It even reacted to people being close to them. So it's yeah.
But it's not a good phone to get when you're the project manager on a Sunday afternoon.
No.
You get a call from the site team and they ask you if you're sitting down.
Yeah.
And then you get the information of everything went good. So.
Yeah, it's hard to tell, but everything worked. Even on the site, the people on site, the line of people that needed to get their response on this, get information about this, everything was handled, and the fire department were really professional. They were not scared at all, but they thought it was quite new. They've never seen this, so but, it worked really good. Any other questions you want to?
I have a few questions. First, the first one is the zoning.
Yeah.
It has the zone plan. Can you please show me where the exhaust from the fuel cells zone are? Because when the fuel cells are operating, at some point they will do a purging, and that will exhaust the hydrogen.
Yes.
Where's that zone?
That will be exactly above the fuel cell. Actually, it's exhaust pipes are above each fuel cells. When it does running, it does occasionally purge, as you know.
And that will not generate.
But that's I think how high tall is the pipe, Christina? 5 meters.
It's 5 meters. Yeah.
Yes. So it's kind of outside of this container itself.
Okay.
Yeah.
Second, if we put this on a vessel.
Yep.
And hydrogen fuel cells are the single source of power generation, would that not give a risk if you only have one fuel line from the hydrogen storage to the fuel cells? If I have a burst on that pipeline, then my total loss of power, that will not be accepted on board the ship.
If you have a single source of power, that's something we have to discuss with class, but normally that's not generally advisable to have a single source. However, with the fuel cell supply, if you want this to be redundant, you need redundant piping, of course, and you need redundant supply. So, of course, keeping the operation going is quite important, as we mentioned with this CAP, this critical alarm and action panel, is able to, if you have a problem in one container, this normally shouldn't be located so close to each other, but on board.
That's right.
If you go to the PNID,
Oh,
No, but you can look at this is from the vessel, and you can see they are separated into different compartments, the hydrogen storage and the fuel cells.
yes, but if you take the PNID,
But that is for a string, this is for the
That's for
land
string test,
yeah, okay.
So that is not for the vessel itself.
Okay,
And that is one of the issues, of course, related to what we found in the hazard. Because, and that will not be allowed on the vessel to have just one source of the fuel.
well, because if I have a pipe burst at the red dot right now, then I will lose everything.
Yep.
I'll have the battery for some time, but I'm not to be able to maneuver.
You'll notice there's 2 quite different things here. There's vessel design and there's getting it all tested on land first. But looking at this, you'll notice that we've got things banked. There was 2 banks of fuel cells, there's 4 banks of batteries, and this is thinking ahead to exactly what you're talking about when you begin to separate these kind of things to give you additional resilience.
No.
It's only to make the test tube.
Yep,
yeah.
and it's, that is correct. Yep. That is what is important for the test as well.
Yeah.
It's not important to just check that you have a separate.
Just have to do 2 separate.
So, but you highlight the fuel supply as one line, right? But if you see on everything else on the system is built for redundancy. Redundant switchboard, we have redundant fuel supply, redundant batteries.
Yes, it was only the pipeline.
Yeah, it's done for simplicity on the
Okay.
test.
Good, and redundant sensor.
Yeah. Yeah.
Hmm.
Redundant control system also. So, and fail safe.
Functional safety.
Yeah, this is an approved safety system for the offshore and the oil market, so it's kind of, yeah.
This is,
Heavy safety.
yeah, this is the Kongsberg safety, so it's not new, it's well proven.
Yeah, it's well. No.
It's a lot of new things into the project, but not the safety.
No. No shortcuts on that.
Giorgio, did you want to ask your question, Giorgio?
Yeah, I see if you can.
I didn't fully understand if the second leak you described was caused by the same source. If this leak was the same one you described in the previous slide, or it was through these valves you mentioned, this pressure release valves.
Yeah, I will explain it in very short.
Hold on.
This pressure transmitter here is the one we detected the pressure drop over time, because when we leave the site, we will close off on the manifold and we will close off the fuel supply. So we'll have some meters of hydrogen inside, and we want hydrogen inside that one. We want to keep that not saturated with any oxygen or any other gases. We want hydrogen in it. When this was pressurized at 15 bars, and we left the site closed off, it would show indication on this one that it dropped approximately 2 bars. So it's actually from a different place than the gasket itself. The gaskets were tight at this stage. You will have valves on the canisters and on the wall, and you will have a main shutoff on the manifold, and you will have a remotely operated ESD valve on the end here. And then you will have the fuel supply lines. So it's actually more than one closed off valve on this pressure. So the pressure has gone somewhere. We don't know where it's gone, but it's gone somewhere. That's what we indicated on that pressure drop. I hope that answers your question, George.
Okay, so you think it's a few different potential sources. That's what you're saying.
Yeah, because of the leakage rate that's defined in the pressure reduction valves, I'm not saying that it's gone outside the pipe. It can be inside the fuel cell and ventilated outside there. So it's the sensors did not detect this at the same time. This was so small that it wasn't detected on one day. It was 10 days. So it's. But it's from that transmitter on the fuel supply line from the gas supply itself, where my red dot is.
Okay, clear. Thanks.
Yeah, no problem. I'll be happy to take more questions.
Did you guys do a lesson learned with Linda about the connections?
We did a we had close communication with Linde when we found all these issues over time. We didn't have a dedicated lessons learned with them, but we had direct communication very closely during this commissioning time. And we also, that's why we had one of these pressure reduction manual valves, this release valve, so that we were able to reduce the fuel pressure over time before we left the site. So they came and installed that, and they also replaced some of the reduction valves that seemed to kind of leak more than we wanted. So claims, warranty claims.
But we have had a lessons learned with Linde and also this PSW, the site owners, after the big leakage.
Yes. It kind of caused another paper mill of things that the project manager did.
What was the result of that? So the procedures were changed after the big leak?
Yeah, some procedure was updated regarding the change of these gaskets. Also, we had an additional course related to together with Linde to get better understanding than of the behavior of hydrogen. As Lars-Petter mentioned, everyone acted as they should during the incident, but it was they were unsure if they did the right things. That is kind of what we addressed then afterwards in the training to make them more sure and secure about the actions they were taking during later incident if it shouldn't occur.
We needed a confidence boost after that incident. When the fire department came, they foamed the whole container and then went in and turned off the manual valve on the canister that was leaking. So it was confidence regarding the clothing you were wearing, if we were able to go in and do it ourselves, things like that. We didn't want to touch it. We didn't know, so we called the fire department, fix this, things like that, in case it were to happen again. It didn't.
We had training before the incident, but I would say that the questions and engagement from the people was much higher on the second training.
More advanced questions also.
Was there any questions coming from the surrounding areas or businesses, or did you get any questions from your neighbors around the PSW site?
We did not. I'm not sure. I'm not heard anything. There was the owner of the site that had some questions. Other than that, I'm not heard of it.
We have it's approximately 100 kilograms of hydrogen, so the fire department were pretty dormant on the evacuation zone, and they were wanting to increase it before they understood what was happening. So it went from 100 meters to 300 meters, and so it was on the borderline of evacuating the hotel at Ågotnes. But we were able, when they saw it, we were able to avoid that. So, yeah.
Oh, we have a question from, is it Maxim? Please.
Yes, thank you. Just a few questions. I think the safety system mainly relies on the hydrogen detection, so the active protection. Did you have any passive protection measures like pressure drop measurements in the system or any excess flow valves implemented at all?
No, that's something we experienced during the commissioning and testing, that would be beneficial to have to detect the leakages. But again, the leakages were so small, it wasn't detected by our gas sensors, which are located at the accumulating places where hydrogen can accumulate. And all we had was this active prevention with the gas sensors.
Okay.
Yeah.
Thank you for that. And the second question, if I may, what are your procedures when you leave site? So do you isolate individual banks of cylinders, or do you just rely on one valve to isolate the whole supply side?
No, what the procedure is to absolutely close the system. That means all valves should be closed, all breakers should be disconnected, and also the pressure should be released to below fuel gas pressure. So we're sure that it's not trying to go through the reduction valves to the fuel cells to supply them with the hydrogen. That's what we saw that because of the leakage rate of the reduction valves. But basically, to make the system, you have to kind of remove one of the items in the fire triangle, right? To make it safe. There's no ignition source on this site when we leave it, so basically close it down, all of it, and reduce the pressure which came after this leakage as an extra point to do. And that went really good for the year we were on site. So.
Okay, thank you.
Any further questions before I hand it over to Edwin or Bala? Yeah.
This is last chance for this section where they still have the presentation up and they can refer to something. So if you have any questions, please come forward. We will get the next speaker ready while we're doing that.
Okay. Thank you for your time, for now, at least.